Hey everybody, this is Alex Merced from alexmercedcoder.com with some cool information. Basically, this video, what it is to explain what sort of the state of things are, what the big deal about TypeScript, about Webassembly is, just to kind of give you an idea of the landscape in web development. Okay, so HTML and CSS do what HTML and CSS do, and they're going to keep doing what HTML and CSS do. But as time goes on, the demands of doing sort of the more, logic programming side of it has always been JavaScript. And JavaScript's a great language. JavaScript has really evolved over the years, a lot of new features, a lot of the, especially now with like async await and a lot of the ES6 spec and beyond, you can pretty much do a lot of really cool stuff. But problem is browser compatibility. Okay, so while the main three browsers, Mozilla, Edge, Microsoft's Edge, and Chrome, for the most part have kind of conversion, are much better in cross-compatibility of their JavaScript engines. Problem is, there's a lot of people who really use older computers, okay, which still are running like Internet Explorer 11 or earlier, and older versions of many of these browsers, which don't have the newer versions of these JavaScript engines that read a lot of this new spec. So when you code JavaScript, if you're using things like async await and a lot of the newer features and syntax, older browsers are like, what's going on? I don't know what any of this stuff is. And this has become a bane for the existence of web developers. So there's a couple different ways of dealing with this. In the JavaScript world, Microsoft created what was called Typescript. Now, Typescript essentially is a superset of JavaScript. What does that mean? It means it's literally JavaScript plus. Okay, so it adds other features like decorators, which allow you to kind of create ways to add metadata to a class. There is typing. Now, some people have mixed feelings about typing, because if you've ever done typing in a language where you actually have to sit there and say, hey, this variable's a number, this variable's a Boolean, this variable's a string, and then the compiler throws errors at you if you don't remember to do it. There's a benefit to typing, okay, which is why people wanted typing in JavaScript, is that it helps you catch errors. Because if the program knows that this variable is supposed to hold an array, and this function is supposed to return an array, then what happens is that for some reason, if you return something that's not an array from that function, or you put something that's not an array, or not a string, not an integer, into that variable, the compiler's gonna be like, did you really mean to do that? I think you have an error here. Okay, this allows you to kind of catch errors you don't anticipate. While generally in JavaScript, usually JavaScript is very dynamic in its typing. I mean, really dynamic in its typing, which I really enjoy, but also can be tricky when you're trying to find an error, because the code is working, because a function can return anything and store it anywhere, so everything works. But unless you put a lot of console logs and you're really kind of making sure you're outputting variables to console on a regular basis, it's hard to catch that, oh, I'm sending the wrong data here. So while the program logic is running, it's not doing what I want it to do. So that's why people want typing. It just allows them to catch bugs earlier and have cleaner code that requires less bugging down the road. Okay, and just is more perfect out of the box. Okay. So TypeScript adds all these features, plus allows you to use the latest versions of JavaScript, of the JavaScript spec, so that way you have access to things like async await and promises and all this stuff without having to worry about browser compatibility, because you would use a compiler, typically using something like a Babel. So what Babel does, it translates your JavaScript or TypeScript down to an earlier version. So you could sit there, use TypeScript, have all these features available to you, code with all the best coding practices and the best coding tools, and then it'll compile it down to like ES5, which I think is where you'd have to go to, how far back you'd have to go to be compatible with like Internet Explorer 11. So that's how you deal with it currently in JavaScript, okay? But then other languages kind of have to go through the same trouble where they have to, if I wanted to program, so right now I could do backend programming with Python with like a Django or a Flask, and pretty much every language will allow you to do server-side programming if you choose to do so. But what about front end? Well, if you wanted to do front end work, to do front end scripting from the browser, what you have to do is you have to use JavaScript. That's really the only game in town. So what a lot of languages do is they'll create what's called a transpiler. It takes one set of code and turns it into another language. So you could code in Python and then transpiles into JavaScript. You could code in Ruby and it transpiles to JavaScript. I think that's essentially what CoffeeScript was, okay? But the idea is that that's basically how all languages get exposure to the front end. But this becomes really annoying as well, because what happens is that as the JavaScript spec changes, so basically you have to make sure that the compiler creates compatible JavaScript. And as the JavaScript changes, then you have to change the compiler. But all you're really trying to do is just do the front end. You're not trying to make JavaScript, you're trying to create front end scripting. Okay? But if you try to add another language to the browser, I mean, all these different browser companies, Mozilla, Internet Explorer, Chrome, they're not going to agree on which languages their browser should support. And they can't support every language because that'd just be too much information for that browser to. Browsers would become huge and verbose and slower because they're compiling so many, they're interpreting so much. So magically, rarely this happens in the world of the internet, where basically everybody agrees and gets on the same page and say, hey, you know what? We need a standard compiling target. So that means not a language that people are going to actually code in, but something that languages can compile to that's more lower level, meaning closer to like machine code, so that way it can run faster. Because JavaScript, is a high level language. So if you're compiling to a high level language, that's the levels of abstraction leads to much slower code. Because when you transpile, you're not necessarily going to create the most efficient amount of JavaScript. Because, you have to make sure your compiler can at least make sure that whatever let's say you code in Ruby and you transpile the JavaScript, it has to do something that does what your Ruby code said it should do, but it might not necessarily do it in the smallest amount of lines of JavaScript code possible. And JavaScript in itself is already essentially inefficient because it's already built on several other sort of layers already. Not that, again, most modern computers are faster, internet connections are faster, that this is less of an issue. But if you want to do like massive 3D gaming in your browser, this is an issue. Okay, so WebAssembly provides that sort of much lower, closer to the metal language that, let's say, a Ruby could compile to. So instead of Ruby compiling to JavaScript, Ruby could compile to WebAssembly, and it would run a lot faster and be a lot more efficient. Okay, because instead of, you could create again code that's going to be at a much lower level of abstraction, a lot less layers in between, far as, hey, this line, first we have machine code, then you have assembly and machine code, then you have, let's say, C on top of that, then you have JavaScript on top of that, and then you throw Ruby on top of that. You have all these sort of layers of abstraction code-wise that just kind of results in a much more, once you finally get the compile all the way down to the very bottom, what you have at the very bottom is much bigger than it really needs to be. So that's the promise of WebAssembly. So these are the kind of things where things are moving towards, and then in the future you might have TypeScript compile to WebAssembly. So you have all the features of JavaScript, but now since it's compiling to like a lower level target, you have, instead of going from TypeScript to JavaScript to wherever, to the browser, you can just go from TypeScript directly to the browser. So you have all the extra tooling that TypeScript provides you and extra features that TypeScript provides you without having to worry about compatibility issues, browser compatibility issues. As long as people still use Internet Explorer, that's always going to be an issue because Internet Explorer doesn't support WebAssembly. Internet Explorer doesn't support ES6. So, but over time that becomes less of an issue. But there's all these technologies that are going to really, once you can embrace them more, are going to be a huge boon to the internet when Internet Explorer finally dies. Okay, so that's essentially what everyone's waiting on. People to either upgrade their browsers or for there to be, a bigger market of people with newer browsers. Okay, not so many, because again, who are the bigger consumers are generally people in older generations. They're gonna have older computers, so this is sort of where the conundrum exists. So if I'm a company that sells stuff and I want to build a website, I want to make sure that everyone sees it. So you as a developer may want to be using the newest tools, but your client wants the extra exposure. So right now that's still a conundrum, still something you have to deal with. So you have to worry about polyfills and all that fun, exciting stuff. But for now, there's stuff to look forward to. Talk to you guys later. This is Alex Merced from alexmercedcoder.com. Make sure to head over to alexmercedcoder.com and join my networking Slack so that we can meet other developers and other people interested in technology and, be part of the community. I'll talk to you guys later.